Okay, so on number 36, we are going to use the same formula that we used on number 31, the APERT formula, since we are compounding continuously. So APERT, like that. All right, and they've given me that we're investing $380, so that's going to be my p-value, and my rate is 7%, so I'm going to write that down as 0.07, so move that decimal point 2 places. All right, so on A, they're asking me to write just the function, so we're just trying to write our formula here. So A equals, I know what P is, let me go ahead and fill that in. So P is going to be 380 e to the 0.07t. So fill in the P and the R value. All right, so that's all they want for A. On B then, they want to know at what time. So I'm looking for T. Will we reach that $800? So 800 and then 380e 0.07t. All right, it's going to be a lot easier to solve this if I get my exponential by itself first. So I'm going to start by dividing over by the 380, and I'm going to keep this as 800 divided by 380 for just a little while so that I can type all of that into my calculator at the same time. So I'm in an exponential form and I'm stuck, so I'm going to change that into a logarithm. So that's going to be a log with a base of e of the 800 over 380, and it's going to be equal to 0.07t. All right, so rather than use the log with the base of e, I know that's the same thing as the natural log, so I'm going to type that into my calculator. So grab my calculator, and I'm going to put in first my natural log, and then I'm going to use alpha f1 number 1 to get my fraction, so 800 over 380, or you can use parentheses if you want to. And then to get t by itself, these are multiplied together, so I'm going to divide over by that 0.07. So t is going to be 10.63, and I'm around that to a 5. And the time on these is always in years, so I'm going to measure that in years. Okay, on number 37, we're working with a logarithm, and I'm stuck, so I'm going to try to change it into an exponential form. And this is going to be a log with a base of 10. So if you ever have a log without a base, it's a log with a base of 10. So in exponential form, that's going to be 10 to the 4th power is equal to x. And so x is going to be, and I'm going to put 4 zeros with that since it's to the 4th power, so 10,000. All right, on 38, we get into our conic sections, and we'll give you some formulas to go along with these conic sections. So I'm going to start by finding the equation of the hyperbola. So I'm going to draw a little picture to go along with this. Let's see what we got here. So it's centered at the origin, and then it has x-intercepts at positive 4 and at negative 4. So I know that my hyperbola are going right and left, so that's going to be there and there. And so I know that I'm going to be working with the formula that starts with x first. So it's going to look a little bit of something like that. All right, since I'm centered at the origin, I know that my h and my k are going to be zeros. Let me jump right back down here, and I'm just going to write that as x squared and y squared. So we've got a center point at 0, 0. So this is going to be 0 and this is going to be 0. So I can just go ahead and write that as x squared and y squared. And then I also know that the distance from here to here, which is my a value, is 4. So a is going to go under the first one, so that's going to give me a 16 right there. All right, then the other piece of information I have here is the slope. So we know that a is 4, so that's going to be a. And so b is the one that's on the top when we talk about my slope in this case, since x is my first one. So my b value is 3, and so b squared is going to be 9. Now they've written this in standard form, so to get this in standard form, and you can kind of look at it and see what you're looking at here, I'm going to multiply through by a common denominator. So 16 times 9 is going to give me that common denominator of 144. So I'm going to multiply each and every single piece here by 144. And this one over here times 144. So 16 will go into 144 9 times, so I'm going to have 9x squared. And 9 will go into 144 16 times, so 16y squared is equal to 144. So sometimes they'll have you change into that standard form. And let's see here, that's going to be answer choice B. All right, on 39, we're working with another conic section. This time we're working with a parabola. Let me draw a little picture of what we have. So with this one, we've got a vertex at the origin. So vertex and the center are kind of the same on a parabola. So we're working with an h and a k value of 0, 0. That's h and that's k. And I want to have a directrix at y equals 4. So that's going to be at 1, 2, 3, 4. We're going to cross the y-axis right there. So I want my parabola to go through the vertex, and I don't ever want it to cross the directrix. So if I draw my parabola here, it would cross, or here it would cross, or if I did it up and down, it would cross. So I'm going to go down with my parabola like that. So it's looking a little bit of something like that. So since it is going down, that tells me that I know that x is going to be the one that's squared in my formula. So I'm going to use this formula right here. Okay, so this one's going to open down. The other thing that I know is that my 4p value is going to be negative. So I'm going to say that p is the distance here between my vertex and my directrix, so that's going to be 4. But again, I know it needs to be negative when I put it in right here. All right, so I know h is 0. I know k is 0, so I'm going to say that my formula originally is x squared is equal to negative 16, and then we're going to put a y over here. But if you look at your formulas, most of these have been solved for y. Okay, so I may need to move something around. So looking at these, this one's working with a 4. I know it's not going to be that one. This one has a negative 16, but it's on the wrong side. It's with my x squared instead of with my y, so that's not going to be it. This one over here, it's with my y squared. I know that in this one, y is not squared. X is the one that's squared, so it's not going to be that one. It's probably going to be this one. And they get this one by moving the 16, dividing over by that, so that y would be equal to negative 1 over 16 with x squared. And so there's your answer right there at C. All right, then the last one on this page, number 40, we are looking at the equation of a parabola again. So again, let me write down kind of what I'm given. So this time they've given me a focus at negative 1, 3, right here, and a directrix at y equals 5. I need a little more space up there. Y equals 5. So here it is right here. Okay, so I know that from the vertex to the focus and the vertex to the directrix is the same distance. So I'm going to say that my vertex, or my center point for this parabola, is halfway in between. So since there's 2 in between these things, halfway is going to be right there. All right, so this time I've got a vertex of negative 1, 4. All right, the other thing I know is that my parabola can't go through the directrix, and I know it's got to go around the focus. So I know again that it's going to open down. So that's going to be important too. You can't see. There we go. All right, let's see here. And finally, I know that my p-value, the distance between either my vertex and my focus or the vertex and my directrix, is 1. Now, since we're opening down, I know 4p needs to be negative, but opening down tells me that x is going to be the one that's squared. So I'm going to use this formula. All right, so let's plug in h and k first. So x goes with x, opposite sign, so plus 1. And I'm going to leave 4p for just a minute, come back to it. And y goes with y, opposite sign, so minus 4 right there. And again, I want it to be negative, so it will open down, and 4p is going to be 4. 4 times 1 gives me 4. All right, so looking at my answer choices, that gives me answer choice A. Good. All right, let's see if we can get through one more before my time runs out. So on number 41, we're trying to sketch this figure here. If I just look at my formula, I've got a minus sign in between these two fractions right here. That tells me that I'm working with a hyperbola. So already I can say it's not this one and it's not this one. Let's see here.